All right, so number 3. Another way we can do problems like this or use expected value is to compare games, essentially, the outcomes of games. And in this problem, you'll see that there's 2 options, and we want to figure out which option will be most profitable for us. So for number 3, you need to borrow money for gas. So you ask your mother and your sister. You can only borrow money from one of them. Before giving you money, they each say they will make you play a game. Your sister says she wants you to spin a spinner with 6 outcomes numbered 1 through 6 on it. She will give you $5 times the number that the spinner lands on. Your mother says she wants you to flip a fair coin. She will give you $8 for heads and $32 for tails. Determine the expected value of each game and decide which offer you should take. So yeah, we're basically going to figure out the average that we can expect from each of these games, and whichever one is higher is the one that we're going to pick, because that means you're more likely to win more money with that game. Okay, so separate it from the work up there. Let's start with the sister, because there's 2 different games here, so we have to look at these at two different expected values, essentially. So the sister wants you to spin a spinner that has the numbers 1 through 6 on it, but then she's going to give you money based on what you spin. So X is going to be the amount of money you get. From a spin. So the amount of money you earn from a spin. Okay, so over here, I'm just going to put 1, 2, 3, 4, 5, and 6. These aren't the actual variables, but these are the different numbers we can spin on this spinner. But we are focused on the number, like the amount of money you're going to get. If you spin a 1, she said she's going to pay you 5 times that number. So $5 times 1 is $5. If you spin a 2, $5 times 2 is $10. She'll give you $10. If you spin a 3, you'll get $15. 5 times 3. So on and so forth. If you spin a 4, you'll get $20. If you spin a 5, you get $25. If you spin a 6, you're going to get $30. Nice. So these are different possible outcomes that you could have. And now we want to look at the probability of each of those. So if you think about a spinner, so I'm guessing it's just something like this, and there's numbers on it, and if you spin the spinner, it'll land on one of those numbers. Well, what's the probability that you land on a 1? 1 out of how many different options? 6, right? There's only 1, and there's 6 different numbers. What's the probability that you land on a 2? Well, there's only 1, 2, and then there's 6 numbers. So again, it's 1 out of 6. The probability of you landing on a 1 is 1 out of 6. Probability of you landing on a 2, 1 out of 6. Probability you land on a 3, there's 1, 3 out of all 6 numbers, 1 out of 6. And hopefully you can see the pattern here. Each number has an equal probability. All right. So now to find the expected value, we multiply and add. So we'll have 5 times 1/6 plus 10 times 1/6 plus 15 times 1/6, right? Keep on going all the way till we get to 30. So we got 20 times 1/6, 25 times 1/6, and then 30. Okay, when you pop that into a calculator, you should get 17.5. So basically, I'm going to add a 0 because we're talking about money. You could expect to maybe get around $17 out of this game. Now, I know that's not an option here, but if you kept playing this game, that would be the average, the expected value. So that's the expected value for the sisters game. Let's look at the game that the mother wanted to play and see what the expected value is for that. So the mother wanted you to flip a coin, but she's going to pay you, right? Money for the flip, money from the flip, however you want to label it, doesn't matter. Now, when you flip a coin, there's two options, right? Either heads or tails. But again, we're not focusing on heads or tails. We're focusing on how much she's going to pay you for landing on those. So if you land on heads, she's giving you $8. So I'm going to put $8. Now, if you land on tails, you get 32. Nice. And those are the only two options, right? That's the only two possibilities anytime you flip a coin. So let's look at the probability of those. Now, we've done coin flips before. The probability of flipping a head on a coin flip is 1 out of 2, right? 1/2. Probability of flipping a tails, 1/2 as well. So again, equal probability, but totally different outcomes. All right, let's multiply. So you can either get $8 times your half probability, or you can get $32 times the half probability. You can pop that into a calculator and then simplify. What you'll get is 20. So again, expected value basically can just be helpful in letting you know which game you might be more profitable in the end. And comparing these values, we have 17.5 and then we have $20 here. Which one's bigger? Definitely the 20. So you would want to play the game with your mother because you're probably more likely to win more money that way. There will be a problem quite similar to this in the homework. All right, let's get one more done, and that'll be it. Done for the week. Then we got finals. During the NCAA basketball tournament season, affectionately called March Madness, part of one team's strategy is to foul their opponent if his free throw shooting percentage is lower than his 2-point field goal percentage. Amos's free throw shooting percentage is lower and is only 53.1%. I'm going to highlight that. So every time he shoots a free throw, 53.1% of the time he actually makes the shot. After being fouled, he gets 2 free throw shots, each worth 1 point. Calculate the expected value of the number of points Amos makes when he shoots 2 of those shots. So this one we kind of have 2 steps actually. First, we want to look at just the expected value of him making 1 shot, essentially. What's the probability that he's going to make the shot? So to start, I'm trying to find my words. If we read this problem again, calculate the expected value of the number of points. So that's really where we're focusing, the number of points that he is going to make after he shoots 2 of those shots. But we're going to deal with the 2 later. We're just going to focus on 1 of those shots. So if he's going to shoot 1 free throw, what are the possible number of points he can get? Well, think about that. If he's going to shoot it, he can either make it or he can't, right? If he makes it, he gets a point. If he doesn't, he gets 0 points. And you might be like, wait, but he's doing 2 shots. Yes, I know. We'll deal with that at the very end. It's easier to kind of break it down and focus on the likelihood of him either just making the shot or not. All right, so let's look at the probability of these situations. The probability that he makes the shot and gets the point is what they give us here, 53.1%. But once again, I want to put this as a decimal. So essentially we're dividing by 100. We get 0.531. So that's what I'm going to put next to my x value of 1. The probability that he gets a point from making the shot is 0.531. So what's the probability of him not getting a point, not making a shot? Well, it's not going to be the same, right? It's not 0.531. That's the probability that he makes it. But you guys remember complements? They dealt with like opposite situations. And that's basically what we're going to do here. So if the probability of him making the shot is 0.531, the probability that he doesn't is going to be 1 minus that. 1 minus 0.531, which is going to be 0.469. So the probability he doesn't make the shot is 0.469, right? Because he either makes it or he doesn't. And they're opposite situations. So we can do 1 minus to get that other probability. So now let's look at the expected value. So if he makes the shot, he gets 1 point. The probability of that is 0.531. And then we add that to him getting 0 points. The probability of that is 0.469. Now when you simplify this, we get 0.531. Exactly what we started with, kind of, with his probability of scoring 1 point. But remember, they actually wanted to know what's the expected value when he shoots 2 free throw shots. What's the probability that he'll get 2 points? So all we want to do to figure out the probability or the expected value of making those 2 shots is we just multiply the expected value times 2. 2 times the expected value. Because this is the expected value of 1 shot. So to figure out the expected value of 2 shots, we're just going to multiply that expected value by 2. So it'll be 2 times 0.531, which is going to be 1.062. So what does this mean? Basically, if he shoots 2 free throws, we really only expect him to get 1 of those shots. We only expect him to get about 1 point, which makes sense, right? He has close to a 50% clearance rate, I guess. 50% of the time, or about 53% of the time, he makes the shot. The rest of the time, he doesn't. So if he's making 2 shots, chances are he's only going to make 1 of those. But again, it's probability, so we have a decimal, so this is the exact answer that you want to type in. But when we think about it in context of the actual problem, yeah, chances are he's only going to make 1 point out of those 2 shots. Okay, so all these problems are similar to the homework because I wanted to cover topics or problems that you're going to see again. So if you're struggling with the homework, just come back and check out these videos again. And hopefully they'll be helpful. If you guys have any questions, please let me know. Shoot me an email. Whatever you need to do. Have a great day.